all of those terms, they collapse to give the same answers. So then you can group all of those. And this one, we do things a little bit different. So what we do, we use a trick also, and we use this common difference, and then we multiply this whole thing by R. So if we take this Tn, and then we put an R here, all right? Then this is going to be AR, this is going to be AR squared, this is going to be AR cubed, up until ARN. Do you guys agree?
Mm.
Hmm?
Why is that so?
Because by asking why are we multiplying by R? Or are
Yeah,
you asking why is it ARN?
no, I'm asking why are we multiplying by R and why is the first term eliminated?
Okay, why is the first two eliminated? Okay, okay, I'm not too sure about that question. But the reason why we multiply by R, remember, in grade 10, when you wanted to convert a number into a fraction, so you've got 0,111 and you want to make it a fraction, you would have to multiply that by something to get it into a fraction. So often in mathematics, what you're going to need to do, you're not going to need to be able to, especially when you have things like this. When you have things like this, that basically say, I don't know how many times this are. So the best thing you want to recreate something similar that can allow you to add and subtract the bulk of the dots. All right. So one of the tricks when it comes to geometric sequences is to basically, because the trend here is to multiply by R, is to multiply by R, is to multiply by R. So already I know if I take this whole thing and I multiply by R, this one replicates itself. Now, when I'm going to say this one subtract that one, this whole thing is going to drop off. Then I'm going to be left with something simpler. So that's why we use the R technique. That's why we multiply by R. So we want to we've got the first equation. We want to come up with a second equation that's largely similar to the first equation that we can to choose that this plus plus is going to be the same, both the two. So we can remove it completely. We can assume that it's going to be the same, if whether it's million or 100 or whatever the case is. In actual fact, the number of terms ought to remain the same. And what that means is that this AR plus N is here. What is the difference between these two? There's the A here, and then there's this term here. But everything in between now is the same. Now, Lusanda, I'm not too sure if my explanation is clear.
No, I do understand because I thought the A disappeared, but then I realized we multiplied it by R.
Yes. So remember, I multiplied by R. So the R here would then multiply to this R -1. So +1. Then my -1 and +1 make up 0. Then I'm left with Rn. All right. So now I've got two equations, equation 1 and equation 2. Equation 1 minus equation 2, or anyhow you want to do it, you can say is Tn minus R. Tn is equals to A, because I've got A this side. I've got A this side, and this A has nothing that's similar to it here. It has no friend. All right, it's going to drop off like this. These guys are going to cancel out with these guys. Then I'm left with this one. But now this one, it's minus ARN. Now, I've taken this complicated thing that I didn't know how many there were. And this is what we're trying to get to. I didn't know what n was here. I didn't know what this complicated thing is. But now I know that if I take that thing and then I multiply it by r, that I subtracted to its original factor, I will get a minus a to the power r to the power n. So it's simplified. Now I can determine what Tn is by taking out the 1 over r. So I have 1 minus r, Tn is equals to a. I can just take out the a as a factor as well. Does this equation look familiar?
Very familiar. Very intriguing.
Very familiar.